So the layers of the Earth, do you know which one of these, each of those are? Lithosphere? So the lithosphere would be these two together.
Oh, the very outside.
Hmm?
The very outside.
Yeah, so this blue layer and then this green layer. And then what about the continental crust? Yeah. And then oceanic. Oceanic. Well, I'm not even reading the writing probably. Okay, mantle. Or the asthenosphere, that's the next one. That is this. Yes. Under the mantle. Or under the crust, sorry. And then, so we did these two, and then we have the mantle is next. And then the core. And there's two cores. What is the outer core? Outer core is the outer core. Inner core. What's the difference between the inner and the outer core? Yeah, there's another difference. One is the inner core is solid, and then the outer core is liquid. So now I need to. So we're going to learn about each of these layers a little bit more today. Okay. So has Mr. Kime talked to you about this at all? So this shows a little diagram of it. You got the crust, and it's less than 1% of Earth's mass here. And then the mantle, 67% of Earth's mass. It doesn't look like it takes up that much, but that's because it takes up more circumference. And then the core is 33%, roughly. And then you have the two different types of crust. Oceanic, which is underneath all of the oceans and the land. And the crust is the thinnest layer of crust. Thinnest layer of Earth. And in the oceanic crust, it can be 2 miles deep, so this area right here, or it can be up to 75 miles deep in this area, the land. And it is made up of mostly silicon and aluminum, which both of these elements are called light elements. And then two different types, yep. One way to think about crust is it's like the skin of an apple. Why could you use that metaphor?
Because it's less than 1%. It's just real thin.
It's thin, it's tough, it's brittle. And then you have the mantle. The mantle is split into 3 parts, the upper mantle, the middle mantle, and the lower mantle. The upper mantle is also part of the lithosphere, which includes both the crust and the upper mantle. The crust and the upper mantle. And then the middle mantle has convection currents in it, and then the lower mantle is the area that's right above the core.
Okay.
And then the mantle is solid, but it's capable of flow. The metaphor that they use for this is fudge or hot asphalt. And why do you think they use that metaphor? What happens when you heat fudge up?
It's like not, it's not completely solid, but it's not liquid either.
Yeah. And when it's liquid, it flows a little bit. It doesn't flow really well, but it does flow a little bit. And then that is what is important for convection currents. Do you know what convection currents are?
That's kind of what I'm with you.
Yeah. So you, at the top, it's cold, and then it is sinks because it's more
dense.
and then it gets heated up, and then it flows up to the top, and that's just a current. It's a cycle. And then we have the core. So the inner core is that yellow part, and then the outer core is that yellow part, and the inner core is the red part. And the outer core is liquid. So write that down if you have it.
Yeah.
And then the inner core is solid, even though it's more central. It's solid because the pressure is so hard that it just pressurizes it. And both of the cores are mostly made up of metals like nickel and iron, and those are called dark elements. That's a little bit of a picture of it to visualize it. So the lithosphere again is the crust in the upper part of the mantle.
Okay.
And then the asthenosphere is the middle mantle.
Okay.
And then you have the inner and the outer core. So does this statement here sound familiar to you from the chapter? What does it remind you of?
Just the tectonics.
Yes. The theory of plate tectonics. That's basically what it is right there. The crust is split into plates, which are these blue and green parts, and then they move very slowly on the asthenosphere, which is the convecting part of the mantle. So you got these two images. What do these two images say? Show you
Different
layers.
temperatures.
Mm-hmm. It shows you the depth and the temperatures. On this one, this is a different picture. You can actually see it. Get the temperatures, then the layers with their depths. So, what pattern is shown here?
The heat.
Mm-hmm.
Yeah.
As it gets,
the deeper it's hotter.
Yeah. Which that makes sense.
Yeah.
So write this down. This is a good rule. Law. Temperature increases as depth increases. So here is a little bit of a table between the crust, the mantle, and the core that kind of compares and contrasts them. The crust is 30, I think probably kilometers, kilometers deep, and then 30 to 300, 3,030 is the mantle. And then from the edge of the mantle to the core, so it's about 3,000 each layer, if that makes sense. And it shows the density. The crust is not dense at all. And then it's a little denser in the mantle, and it's very dense in the core. And you can also see the different types of elements that are in each layer. These are both metals, dark metals. And then you can see the temperature increase and the pressure. It really increases between these two.
Yeah.
And then here's another rule based on this table above. Density and pressure increase as depth increases. So you put both of those rules together and you have temperature, density, and pressure increases as depth increases, which kind of shows you how Earth acts and how plate tectonics happen. Then if you want to watch a video, you can. I'm not going to show that. Probably won't enjoy it too much, I don't know. So that's all I had for that lecture. I didn't really want to go on to the other lecture until the rest of the kids were back. So you can just work on your project and your review. Your review is due Friday. Okay. And then your other project that we really haven't started yet is probably due next Friday, I guess. Hopefully we'll be able to do our lab tomorrow. You're going to be here tomorrow. Okay. You're not going to disappear on me? Okay. Hope not too.